The topic for this video is the HTML Geolocation Application Programming Interface, often called API. We'll explore how to access a user's geographical location within web applications. This powerful tool allows websites to request and obtain the user's current location, enabling various location-based services and features. What exactly is HTML geolocation? It is an HTML5 API that enables websites to request a user's geographical location. It is important to note that it requires explicit user permission for privacy reasons. This feature works seamlessly across both desktop and mobile devices. It provides coordinates, specifically latitude and longitude, along with additional data related to the user's location. Let's examine how geolocation works. Here is a basic example of using the Geolocation API. The code first checks if the navigator.geolocation object exists. If it does, it means the browser supports geolocation. Then the getCurrentPosition method is called with two functions as arguments: show position for success and handle error for any errors. If geolocation is not supported by the browser, an alert message is displayed to the user. The Geolocation API uses the navigator.geolocation object to access the user's location. When called, the browser prompts the user for permission before sharing location data. The API determines location using various methods like Global Positioning System, that is GPS, which is the most accurate and commonly found in mobile devices, Internet Protocol Address Geolocation, Wireless Fidelity Positioning, and Cell Tower Triangulation, again more common in mobile devices. Let's explore the core methods of the Geolocation API. The first method is getCurrentPosition. This method retrieves the user's current position as a one-time request. The syntax is navigator.geolocation.getCurrentPosition, which takes three arguments: success callback, error callback, and an options object. It returns latitude, longitude, and other data. User permission is required to access the location. Options can specify accuracy and timeout, among other things. Another method is watchPosition. This method continuously monitors the user's position and reports any changes. The syntax is navigator.geolocation.watchPosition, which also takes the same three arguments: success callback, error callback, and an options object. It is useful for tracking movement and returns an ID that can be used to stop watching the position. However, note that this method can be battery-intensive on mobile devices. The position object contains valuable data about the user's location. Here's an example of how to access position data within the show position function. You can access latitude, longitude, accuracy, and timestamp from the position object. For example, the code logs the latitude and longitude as the location, and the accuracy in meters. The position object includes the following properties: coordinates.latitude, which provides the latitude in decimal degrees, representing the north or south position. Coordinates.longitude, which provides the longitude in decimal degrees, indicating the east or west position. Coordinates.accuracy, which specifies the accuracy of the coordinates in meters. Coordinates.altitude, which represents the height in meters if available. Coordinates.heading, which indicates the direction in degrees, ranging from 0 to 359. Coordinates.speed, which represents the velocity in meters per second. Timestamp, which indicates the time when the position was acquired. Error handling is crucial in geolocation to manage potential issues. Here is an example of how to handle errors in geolocation. The handle error function takes an error object as input. Using a switch statement, it checks the error code and logs an appropriate message to the console. For example, it handles permission denied, position unavailable, timeout, and unknown error cases. Common error codes in geolocation include permission denied, which occurs when the user rejects the location permission request. Position unavailable, which means the device cannot retrieve the current position. Timeout, which indicates the request took too long to complete. Unknown error, which signifies an unspecified error occurred. Best practices for error handling include always implementing error handling, providing user-friendly error messages, and offering alternative functionality when location is unavailable. The Geolocation API offers an options parameter to fine-tune location requests. Here's an example of how to use the options parameter. The options object can include properties like enable high accuracy, timeout, and maximum age. The enable high accuracy property, when set to true, requests the most precise location possible, but may be slower and use more battery. The timeout property specifies the maximum time in milliseconds to wait for a location response. The maximum age property accepts cached positions that are not older than the specified time in milliseconds. Default values for these options are as follows. Enable high accuracy defaults to false. Timeout defaults to infinity. Maximum age defaults to 0. Let's explore a practical example and various use cases for the Geolocation API. Consider this example of displaying a user's location on a map. The Show Location on Map function takes a position object as input. It extracts the latitude and longitude from the position object. Then it creates a map centered at the user's location with a specified zoom level. Here are some practical use cases for the Geolocation API. Navigation and maps, which is a very common application. Local search results to find nearby businesses and services. Fitness tracking to monitor outdoor activities. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.